Look, 5 years from now, we won't be talking about the theory of what it would be like to automate infrastructure on top of this hypergraph of functions. This will be the way you work. And whether you're using System Initiative or you'll be using whatever the system is that somebody builds that works like System Initiative, somebody's going to do to me what I did to Luke. They're going to look at System Initiative and they're going to be like, this was really smart, except for these 5 things that were dumb. And so there's going to be like competition. There'll be multiple different ways to think about it. But we're going to look back 5 years from now at the way we built infrastructure and the way that we've been doing it so far as like a weird dark age.
Abnormal DevOps Iterations.
And here we are. This iteration is with nobody less than Adam Jacob, who is a founder of Chef and System Initiative. So, Adam, first of all, how are you?
Oh, I'm good. Can we talk about how dope the demo is? The like intro video is, though? That was incredible.
Incredible. It's just AI generated music.
Yeah, I know. And also, like, it felt so pro, right? Anyway, sorry. That was awesome.
You are the second one mentioning this in my head because the first one was Nigel Kirsten.
Yeah,
so
I was not ready for it. I did not see that coming. What a delightful surprise.
Cool. So I will. Obvious question. What are you doing these times?
What am I? I mean, I'm CEO of System Initiative. And System Initiative is the future of how you're going to do DevOps automation. We've been working on it for the last 5 years. It's like a legitimately new primitive to think about how to build all of this kind of automation and do this kind of work that we do. It makes things, it's one way to think about it is that, it makes things sort of easier and safer and faster. But mostly what it really is like it's more intuitive, it's more collaborative, and it's more powerful than the primitives you have now.
Yeah, indeed. I remember a talk from you in Ghent 2 or 3 years ago where you introduced the concept of infrastructure as model, which is a wonderful term.
Yeah.
I guess System Initiative embodies this concept in some way.
Yeah, for sure. I mean, what basically my experience and I think the evidence of everyone's experience kind of shows that, like, if you look at what happened in that first generation of people who adopted DevOps and who sort of went down this path of, really automating a lot of things, and we had a dramatic improvement from the status quo. So if you roll your head back to 2007, 2006, and we were all doing everything by hand, mostly still, right? Like, and you look at the improvement we made, it was dramatic, right? Like, it is way better now, and we can do much more complex systems with fewer people, but in a huger, much wider array of technology across lots of different platforms. It was real improvement. Also, it kind of jumped up and then plateaued like immediately. If you look at how the outcomes have been, we've replaced most of those technologies multiple times. Like, we replaced what we were doing for configuration management. Kubernetes happened, Docker happened, on and on and on. We've riffed on the theme. And if you sort of track how companies are doing when they adopt these techniques, regardless of the technology that they're adopting, they kind of fall into the same sort of middle ground of kind of like, it gets hard. They get kind of ground down. The latest DORA report, the last couple of years, we've sort of moved the needle on what it means to be a high performer. Like, you can be a high performer now in your DevOps transformation if you can deploy once a week with a 40% failure rate. And like, that's high performance. That's the best we can do. And the answer is yes. Broadly speaking, for most of the industry, that's sort of where we landed. And that's not a whole lot, that's what we were doing in 2009. Like, that was what we were enabling way back when. And, people did better than that too. But like, we've sort of been stuck in this. In if you really look at the outcomes, we couldn't improve. And so, yeah, System Initiative was our attempt to figure out why that is. And it's kind of in the name that our supposition is that the problem was the way we were asking people to work was wrong. That the way the system itself was constructed, the way that we were putting together things in pipelines, and we were encoding the infrastructure as code, and then we were gluing all these different tools together into some kind of life cycle, and then we would try to put a platform abstraction on top of them, which would always be leaky and wouldn't work for all the things we needed. And like that shape of the system was the problem. And so System Initiative is our attempt to step back and say, okay, if we've been just looking at the problem a little wrong this whole time, and this was a reasonable approach to take, but we've sort of found where the edges are. What would a new approach look like? And how would we build one that has the potential to give us order of magnitude better outcomes?
And so how this new approach works like, if you have to describe a system initiative to a technician, so to a good old DevOps engineer, how would you?
Yeah. So we sort of did three things, right? And I'm just going to be maximally nerdy. So like, this isn't, I'm not product pitching you from the top down. We're just going to go from the bottom kind of. So if you think about how we do this work now, like let's use infrastructure as an example. So like Terraform, Pulumi, CDK, sort of that part of our space, right? So the way that works is you create a source code repository, you write code that describes how you want your infrastructure to be, right? And then you stick that in some kind of pipeline, right? Something, let's call it GitOpsy, but it doesn't have to be GitOpsy, right? It could be whatever. And then you run that thing every time you want to make a change to the infrastructure. And then that thing goes and does it. It tracks state, right? There's a couple of things there that start to get in your way. One, we sort of take all this information about the real world. So, what we're doing is building infrastructure in the real world based on this declaration. But the path of that information flows is only one way. It's unidirectional. It goes from here to here, right? The bummer with that is the infrastructure is not unidirectional, right? There's plenty of ways people could create it. It changes its state all the time. We got a note from Amazon earlier today that some of our infrastructure was degraded and they were going to replace it. Like that didn't happen in my state file. I didn't declare that. I didn't declare that it was degraded in my Terraform, right? So there's like a mismatch there. The other is that data is very useful. If you think about like other things that might need to use it, it's really interesting to know, like, for example, my Docker container knows what ports I expose if I specify it in the Docker file, but I can't use that information to use inside my Terraform to expose that port to a load balancer that I provision with AWS, because they're locked up. They're different, right? One's in the Docker file, one's inside of my HCL. Another problem is the feedback loops are brutal. So, right. And the more you do this, the worse it gets. So if you think about how long do I know before this change I'm making is good or bad? And how do I know for sure that it's going to work? Like it gets bad, 20 minutes, 10 minutes, half an hour. I've seen hour long sort of just plans where it's just like cranking through, like, what do I think will happen? And think about how much state can happen in between and sort of how much you need to know. And then we start building platform abstractions on top of it, and it just gets worse, right? Because the same fundamental underpinnings just then get abstracted away, which doesn't remove their shortcomings. It just sort of keeps us there. So how we think about it was looking at that problem. The first thing you have to do is turn all that stuff back into data. So you have to, instead of thinking about it as code first, you have to think of it as data first. And so we do that by building digital twins of digital things. So basically, how do we build a simulator, basically, that says, hey, you have like an EC2 instance. Great. Amazon gives you a model of a server. We build a model of that model, right? And then we track both sides. So if you want to change the model, you can do that in like the hypothetical. We call that a change set, kind of like a branch. And then we also track the real world, which is tracking the actual state of what that thing is. And then once you have all that information as data, you need to be able to program it so that the model responds to your own policy, to your own behavior, to do the things you want it to do, so that we don't lose any of the power that we get from the existing primitive. So we do that by constructing the model out of this hypergraph of reactive functions. So rather than writing code that describes, what your declaration is, instead what you do is program this model to understand like what your policy looks like. So when you want to define like what an AWS resource is, you write a little TypeScript code that describes all of its properties. If you want to set those properties, you're actually setting a function where the input is whatever the value is that you want for that property, and the result is the output of that value, right? So you can think of like, if I want to set it to a string, it's just like an identity function that says like, hey, the value is X, is value still X. But if I want to make it dynamic, I could just override that function and do whatever I want. So this opens up all kinds of interesting things. So for example, when you're, using this simulator, I can start to write policy that says, hey, I want to analyze my security posture across all of the border gateway devices I have. And so you can write a function that says the inputs are all the border gateway devices. Then you can analyze it in that function body and return the results, which then tell you, is it good? Is it bad? Do I like the configuration? Is it misconfigured? According to whatever you want that policy to be. Another example here is like when you're doing network analysis. So you want to think about like, do you have overlapping CIDR blocks in your VPCs? Like that becomes a really easy question to answer because all that information is here as data. You can just grab every VPC as an input to a function. Then you can calculate over the top of it and return what you need to return. So then on top of this hypergraph of functions, we provide multiple different kinds of interfaces to work with the information. So when you're doing infrastructure as code, the interface we provide you looks like a living architecture diagram. So basically you can like interact with this architecture diagram. When you're doing that, what you're really doing is programming this hypergraph of reactive functions in a way that just sort of makes sense. And then you can slice it up into multiple views. So you can say, hey, here's my like low level networking view. Here's my application view that only has the specific things that the app people care about. They can then program and extend those models, their deployment structure, or, we do things like change our tracing level dynamically. Like all that stuff can be programmed inside System Initiative to sort of allow you to work in different ways. And then, so another kind of analogy to think about what System Initiative does is the way we work now is the moral equivalent to writing a video game in Vim, right? You could do it. And we wrote lots of video games that were really good. But if you want to create crazy giant AAA games, it's a lot easier if you use Unity, because Unity has a model of how a video game is constructed. And we collaborate on that model. So, there's people who are core game developers. They're in Unity writing code in an editor. There's people who are constructing scenes. They're using a different interface. There's people who are, doing specific modeling. They're using yet another interface, right? All those different pieces can exist and work on the same code base because what they're doing is programming the model of the video game instead of programming the video game from the ground up. And that's essentially how System Initiative thinks about it for infrastructure. Yeah.
Well, which on paper looks quite impressive. And the typical question,
I mean, in reality, it's quite impressive.
Okay.
Like it exists. You can come use it right now. It's quite impressive.
Yeah, I tried it when it was launched, but actually I don't have the real use case for my personal very few needs. But some questions here, just to tickle a bit your... First of all, you have this concept of mapping one-to-one, some kind of resources. Now, mostly, maybe only AWS resources for the moment, right?
Yeah, it's not only AWS, but yeah, like you can model anything, but yeah, our focus is AWS for sure.
And starting from AWS, there is a huge amount of things on AWS. Mm-hmm. So and for each, let's say, resource in AWS you manage, there are a lot of parameters, configurations, settings,
so many.
On,
yeah,
which keeps on evolving, maybe over time, no? API versions and so on. So how hard is to keep track of changes and cover, let's say, first of all, have coverage of a single resource which you already cover fully. Because one thing is I create or manage an in-situ instance.
Yeah.
One thing is I manage all the nuances and parameters and whatever is related to the EC2 instance on AWS.
Yeah.
How hard is to keep track of this and map one-to-one?
Yeah. It's easier to do it one-to-one than to try to abstract it. So, if you compare the
Okay.
problem to like creating a Terraform module or creating or provider or to like cross planes definitions, it's a little easier than it is to create those because I don't have to change the behavior. So like, for example, when you use Terraform, what you're doing is writing a declaration that then the system figures out how to take that declaration and apply it to the world. So like, for example, if you change a property, there's some properties about an EC2 instance you can't change once you launch them, right? Like, and if you decide you want to change them, the only thing we can do is delete the instance and then create a new one. So in Terraform, it just sort of does that for you. And you just have to know that that's what's going to happen, right? When you if you touch the magic property that lets you do that. System Initiative thinks about it differently, right? Like what you're doing is interacting with this simulation. And then what we're doing is tracking what it is you're proposing should happen in the simulator. So like you can't, when you think about the EC2 instance, rather than saying, I changed the declaration and therefore I'm going to delete this thing and rebuild it. Instead, what you would do is like launch a new one, right? Like you would make the change in the simulator that's like, oh, I need to build a new instance because I have to change its size and I can't and there's no API call that allows me to automatically auto scale it. So what I'll do is like cut and paste that thing. Now I've got a new one, configure that one correctly, and then I want to delete the old one. And that motion, because you're sort of doing it in the architecture diagram, we're tracking what the changes are you made to the simulator as a series of small operational transforms to this graph. And then we can use those and we can replay them. So this is a long-winded way of saying, because we're interacting with these one-to-one models, building up the model is actually kind of more like just wrapping the existing behavior of how the cloud thinks about their world. And I don't have to abstract it. And so like one thing we do now is we're starting to use AI to just generate the schema and then generate the functions for you from the specification. So you can like, if there's something we don't have coverage for, in a minute, you're going to be able to like go into the editing screen where you can add new models. And then there's the little AI Sparkle button, and you can just feed us the AWS endpoint that you want us to model and hit go, and it'll model it for you. And it just like, and it's kind of amazing. It catches like validations, complex things. Sometimes the AWS docs will say things like, hey, this field is only valid between these two Unicode code points, and like AI is great at like writing a regular expression that is like, yep, this is only valid between these two Unicode code points, and like just sort of does it for you. So, in the beginning, we were sort of building them all by hand and it was artisanal, and it does take a long time to sort of build those things by hand. Now we're getting to the point where we've built enough of them and we've seen enough of it in the wild that we're starting to do that more automatically. And I think, hopefully sometime in Q1, like there'll be some pipelines that are actually just like looking at all that data and then transforming it into a shape that allows us to then automatically sort of gain a lot of coverage really quickly. What's tricky there tends to be the relationships between different pieces of the model. So it's not so much how do I model an individual component. It's more like knowing, well, actually the way people compose something like a WAF rule, if you look at the API, it's this incredibly enormous like JSON document that describes every possible thing you could ever do for WAF. You probably want to break that into smaller compositional objects because working with it as a single huge blob just makes you want to die. So like those are the trickier parts, but just getting it modeled is actually pretty straightforward.
So you are already relying on AI to build some kind of automatic code. First of all, what models are you using behind under the hoods?
We're just using OpenAI right now.
Okay.
Yeah.
And are you seeing, the answers are always correct, or the usual?
Yeah. I'll summarize my experience of doing it this way as amazing, because if you think about this class of problem and trying to do it procedurally, it's like kind of impossible to imagine how we would do this. Like in particular, like extracting a validation for a description in plain text that's just embedded in a man page somewhere. Like that's hard. Like because it's not like the people who are writing those docs are writing them consistently. You know what I mean?
Yeah.
So there's this incredible thing that the AI is doing for us that I don't know how to write it procedurally. I'm not sure anybody could. And it is doing a really good job of pulling those things together, coupled to what is, I think, the most frustrating interface to a programming task that I've ever experienced. Like prompting it correctly and getting it to like behave in the right way is shockingly annoying. When you think about using it as a developer. I think what I'm starting to learn, and what I think is becoming more true, not just for me, but sort of the industry broadly, is that what you're starting to be able to do is, if you start to think about breaking those problems down ever smaller, our first passes at thinking about how to use AI was basically, we're going to build this God machine that takes in all the information, and then you just ask it to do whatever you want it to do, and it'll go do whatever the crazy thing is. I think what we're seeing now is that it's good to have a giant machine that can basically you can think of it like it's the best thing we've ever invented for transforming data from one shape to another. And that's because that's what it is. It's incredible at basically just transforming information from one shape to another. If I want to go from text to video, it'll work. If I want to go from text to text, it'll do it. Like, it's incredible at doing it. It's really, really cool. But when you break it into smaller and smaller problems, when you think of it as like, here's my micro problem, I want to translate this long PDF from a PDF to a JSON data structure that looks like this and extracts only the information I need into the fields I want. And then I'm going to use that as an input to yet another call to the AI and be like, well, I'm going to use this smaller piece of information to generate this tiny piece of output. And then I'm going to collate that with another tiny piece of output. And so like that melding of the AI into what looks like a much more procedural piece of software, I think that's kind of where it's going for everybody. It's just not evenly distributed yet. And that's certainly what's happening inside System Initiative, right? So like, when you think about using like attacking that problem of like, how do I automatically generate a schema for like WAF v2, even the description of WAF v2's API endpoint is bigger than the largest context window available. So like, you have to build something procedurally to break that up into information that you can process that then allows you to do it. So like, but you can do it, and you couldn't imagine doing it without that technology. And so it's kind of incredible.
Yeah. And so, by the way, these remarkable results are already happening after, I would say, 2 years of ChatGPT and, let's say, the rise of generative.
I've been trying to do this for 2 years. It didn't work until 6 months ago.
Right. So this means that in a few years, only, I don't know, who knows what is going to be happening in terms of blending of AI-driven code, managed code, and maybe agents who actually do something on infrastructure.
Yeah, maybe. I'm less excited about agents that are doing stuff on my behalf because, like, what I've seen so far, which doesn't mean that there's not some other technology coming that somebody's building right now that will change my perspective. But like, what the machine is great at, what the technology is incredible at, is transforming data from one shape to another. And so when you think about asking the agent to act on the world and then do something, like, yes, you can sort of squint and imagine that as a series of data transformation problems, but I'm not convinced that it's that great to do it. You know what I mean? Like, when I think about putting it in the control loop, for example, I'm pretty sure that at some point we're going to have an interface in System Initiative where you can ask it to play with you, where like the interface is multiplayer, right? And we have this living architecture diagram. There's no reason that I wouldn't want you to be able to prompt an AI to be like, hey, can you do this for me? And then have it do it and see the results in this change set in real time. The same way that if you and I were working together in the workspace in real time, I could be like, Alessandro, can you do this? And I'll do that. And then we collaborate together. So like, of course you'll do that, because that's kind of a data transformation problem. I have a text input of what I want to see. Please give me the output in this other way and transform it. And like into API calls to System Initiative, which then solves this problem. When I think about like agentic response, where it's like, hey, I want to monitor the system and then I'm going to automatically do it. And then I'm going to behave. I'm going to monitor the outcomes and then I'm going to make new decisions. Like, I'm not sure that it's better than the procedural stuff you would have written at the point where you're making those decisions, because likely, like, I don't know that it's going to be better at making the, should I go left or should I go right decision than you would be sort of doing it procedurally. I think the future there is going to be that the lines there get very blurry between like, when am I calling into the AI and when am I doing something procedurally? And instead of thinking of it as I feed it to the AI and the AI sorts it out, it's going to be more like, nope, for every one of these tinier steps that is about this moment of data transformation, I'm going to use the AI, but otherwise it looks like procedural behavior. We'll see.
We see. But I mean, I see one thing in this, but actually in the trend of the IT industry, this rising complexity, which is getting exponential under the hoods, and we try to make it simpler and simpler in the, let's say, user-facing interface. And I wonder how another gap you are adding in some way with the System Initiative. You are handling and managing complex cloud infrastructures with this visual interface, point and click. People already told you, no, why not Git and why a web interface to do this? But besides this, we add another layer of complexity where if you know what you do and what is behind and how you interact with what is behind, you can handle problems and new situations. If not, you are lost.
Yeah. I mean, this is just sort of segmentation. Like, if you think about, how many people know how their cars work? Like, really know how your car works. And, you used to be able to know, right? Like, if we bought a Model T, you and I would know how it worked because it's not that complicated, really. Now, to use it is incredibly complicated, right? Driving a Model T, not breaking your arm when you start it. There's a million ways that thing would cut you that you would not suffer, even to like drive down the street compared to a modern car, but you could understand it. And, the amount of complexity that goes into a modern car, you kind of can't understand it. And I think when we think about complexity and we think about who we serve, anytime that you are building tools for other people and your starting position is simplicity, I think you're getting it wrong. I think your starting position has to be, how am I going to accelerate the ability for the people who are the best in the world at this problem to solve it? Because if I can solve a hard problem for the people who are the best in the world, and I can start to then think about how those solutions would behave semantically differently for people who have less and less expertise. So for example, like in System Initiative, you can build these management functions that are essentially like a template, but that also can do like day two kind of operations. And so, when you think about how to describe application deployment, what'll happen is you're going to build a component that says, what is the model, the semantic model of an application inside your environment? There's not one model. Do you know what I mean? It's different depending on your own space. So, but you can define this high level abstraction, the application, which could then call into other models and call their management functions in order to generate the infrastructure that you need. So if you think about like, I need a VPC at the bottom, then I need, an ECS cluster that I'm going to deploy it to. Then I need the task definitions for my individual application, which is composed of containers. And then I like need to think of those relationships. Like what an application developer could have is a view that just says, hey, here's your application as a component. here are the things you can do with your application. You could deploy it, you could restart it, you could, move the trace level up and down, whatever it is you want to be able to do. And then they interact mostly with that layer. And what they have are links to the lower layers where if they need to see it, if you need to understand how the ECS cluster is put together, great. Like go look at that view and see how the ECS cluster that's running your task is built. If you need to understand the network, go do that, right? And that ability to compose those things, to separate out like the idea that I have, when we build abstractions in software, what we're doing is usually enclosing the underlying behavior in a way that you can't pierce. That's why we abstracted it. In System Initiative, we're not abstracting those things from you. We're just letting you manage them. So like, instead of thinking about it as like, I run a template and, and it generated this VPC for me, and now I can't touch that VPC because it was generated from a template, you can just go touch it, just go change it, just go tweak the behavior. And that management function can be, you can detach it, you could keep it, you could run, you can do whatever you want. That flexibility is unique. And it's the kind of thing that starts to show you how you can layer in expertise so that, if I'm a person who just needs to deploy my application, I can just work at the semantics I understand about the application. And other people can work at the semantics they understand, and we can share the information. That works because we've turned it all back into data. If it's not data, I can't do it because I come to an application developer and I'm like, well, they're like, well, I need to understand how the infrastructure works. And you're like, well, go look at this Terraform repo. And you basically told them to go fuck themselves, right? Like, that's not a thing, especially if it's like, well, there's actually nested Terraform repos. I got 4 Terraform repos that tie together, that take their state files, that get imported and outputted from each one. But hey, don't worry about it. It's all just code, right? Like, it's going to be easy. We'll stick it all behind Backstage and you won't see it anymore. Like, no, it's insane. It doesn't, like, of course it's not working for us. And that's the way to think about complexity, is that like, if what we try to do is remove the complexity, it won't work. It'll never work because, like you said, it's only getting more complex. There's only more options. There's only more time. There's only more stuff. And so like, whatever the new automation stuff is that we're going to build, it has to be designed to handle an infinite amount of complexity today and stuff it's never seen before tomorrow. And like, that's why it's hard to build.
Yeah, sold. It's you are convincing. System Initiative is open source.
Yes.
As a chef was, and that's a great thing. And actually, in the how you present the open source thing is a sort of a Red Hat way. You can use the software, even build your tools on top of the software. Just remove the trademark, basically.
Yes. Yeah.
Are you seeing some good engagement from the community in terms of both pull requests on the code base and contribution? I know there is this contribute
of like
button.
assets. Yeah, we're seeing some contributed assets. Yes, we're not seeing a ton of contribution directly to the code base. It's a complex code base. I mean, System Initiative it's 5 years of R&D, and it has things inside of it like a custom graph database layer that like writes to memory first and then flushes to disk, and then like it's a complicated big system, and in order to deliver all of those things that it needs to do, it's like complex and getting complexer. Like it's we added a Reebok layer that does custom authorization called SpiceDB. That's yet another thing you have to run. Like even to start the development environment, like you have to have a pretty pro machine. Like if you want to just like fire it up on your laptop, it better be a meaningfully beefy laptop because it's getting pretty big to be able to run. So that's part of the sort of barrier to contribution. I think that'll increase sort of as usage goes by. Like one of the things we learned from the launch in September was that I sort of expected that there would be kind of a longer tail of people who needed less of the more fancy behavior. like when they thought about like how you used infrastructure as code or what your requirements were, like maybe you needed less about like complex authorization, or you needed less templating, or you needed less of those things. And we just heard really loudly that everybody needed it. And it was all the same 5 things. And it didn't matter if we were like talking to a bank or if we were talking to, a tiny startup. And I think that's because the level of sophistication that's in people's infrastructure as code setups now is actually quite high, right? And so, what we've been doing for the last couple months has been sort of taking that list of 5 things, which is basically like templating and management functions, authorization, views, being able to sort of split things up into customizable views, and then more asset coverage and a few other things, and really getting it in a spot where people can really easily see what the path is to move from the infrastructure as code that they do today to system initiative tomorrow. So I think as that happens more and more of those people start to convert, I think you'll naturally see more people starting to contribute to the core. But if that doesn't happen that way, it'll still happen. It'll just happen because we start to make a bunch of money. And as soon as you start to make waves in how that space works, like competition is your reward, And so like I fully expect those things to happen. It's hard to say how exactly they occur. And for us, like open sourcing system initiative is more a strategic bet that I believe that we've actually built a new automation primitive that will fundamentally change the way that we run like all the largest, most complicated infrastructure on the planet. That's what it is. And if that's true, and I want it to become everything it could possibly be, it has to be open source. Like you have to be able to take it and do things with it that I don't want you to do, or that I'm not interested in doing, or serve markets I don't want to serve. And you have to be able to make money with it. Whether I like that you make money with it or not, it's irrelevant. Like what I want is that technology to live up to its full potential. And it can't do that if it's just mine alone.
So let's say I have a company which has my workload on AWS with typical things that you have on AWS, which are covered by system initiative resources and components. An expert of system initiative, like how many people are working in the company now? Just
17.
17. Okay. So an expert in system initiative, how long does it takes to map the current infrastructure inside the system initiative? How fast for people?
Not that long. Usually the way you start to map it, we've built some prototypes in the past that do like discovery, where you kind of start from like a credential and then you just sort of map everything that's in the account. That sounds cool.
Mm-hmm.
But it's actually kind of not what you want when you're migrating, because you actually kind of want to migrate in pieces. Like you want to think about like, okay, here's a piece of what I do that's like easy to understand, that allows me to sort of gain some trust in the system. Do you know what I mean? Like you don't really usually think about being like, well, I'll just turn off all the old automation that I've been doing tomorrow because this new thing imported all my junk. Like that's a kind of a crazy path. So instead, what we tend to see is people start from a piece of the infrastructure, right? You start from networks, or you start from an application, and you port that. And that porting process either means importing the existing resources, right? So saying, hey, here's what I have now. I want to import this VPC. I'm going to import, this cluster that I'm running on ECS or whatever, which you can do in System Initiative. And so you sort of lay the resources out and then import the existing data. And then you use that to sort of compose what already exists. Or you just start modeling it again net new. And, which one's the right maneuver just sort of depends on the environment, right? Like it's a little circumstantial to like, what is it you're trying to do? We have some work that we're going to start here in the new year to sort of look at something like a Terraform state file and then drive that import process from the state file. Because I think that sort of speaks to that, like people do actually tend to think of this today as having sort of layered boundaries between different pieces of the architecture, right? There's like an anti-pattern in the infrastructure as code world of having just a huge blob of all the stuff in one giant repository. Like instead, you break it into smaller pieces so they can change independently. And I think my guess is that that's actually going to be the way people think more about migrating is I've already broken my problem into smaller pieces. So now let's like look at the migration path from what I have now to system initiative also as a process of smaller pieces, right?
Okay, so that's how you would suggest to follow the sort of the procedure to migrate to system initiative step by step on a single existing infrastructure, or maybe.
And we're still a little learning how people are going to do that. Like it takes a minute and people trying it to really get to a spot where you're like, well, yeah, this is the best practice or whatever. Like I don't like. We don't know yet exactly what the right best practice will be because you have to actually do it to know. But those are the ways that we're doing it now, and they're working.
Okay, and there are some good cases of companies who migrated and started the migration and then have received.
Yeah, yes and no. Like a lot of what we heard was really clear feedback that was like, this thing's great. It's how I want to work in the future. I need these 5 features, I need templates. I need higher level semantic abstractions. I need comprehensive access control. Like we heard very loudly that people loved the product. They loved what it was doing. And they just needed a little bit more of what I thought were more enterprise looking features, but turn out to actually be ubiquitous, sort of whether you're in the enterprise or not. Right. So there's been some migration, but I would say that it hasn't been crazy high, simply because the feedback we got was that. The flip of that, though, I sent an email to everyone who like sort of who signed up, tried System Initiative and stopped using it, and was like, hey, why'd you stop? And I got like a 15% response rate, which if you're not a person who sends email to randos is incredibly high. Like it's a crazy high open rate. I mean, response rate, forget about open rate. Like it would be a great open rate, but it's a crazy high response rate. And, what we got back from people was, I'm very excited. I really like how this thing works. Here are the things that I need. And then like a long dissertation about like how much the status quo sucks and like all the things they want to see be different. So like, it's still early days, we're only a couple months sort of into the world where we told people that they should use it for real and that it wasn't going to like eat your infrastructure and you weren't going to lose your data. So it's still early in the journey, but yeah, we're seeing some teams sort of counterintuitively, the teams who have the most sophistication around infrastructure as code are the teams who are most engaged with System Initiative. Because they sort of have the most to gain in some ways because they really see what the pain looks like at scale. Whereas like, the smaller teams or folks who have a little less complexity there, they feel the pain, but it's perhaps a little less acute,
Well, I can confirm from my very little point of view that System Initiative is in the cool list. Just yesterday, I had a call, an episode with Bern Erk from iSing, and he mentioned you and the System Initiative as one thing to look for in the future. So,
yay!
I guess there is some hype in this industry, I would say.
Yeah, we're undeniably cool.
You don't have to say it. You should not say
other people will say it,
Other people.
Yeah, does it make me less cool if I say it? I guess it does.
Well, never mind. They are cool anyway.
Thanks, man.
That's interesting. So I would say let's stop for a moment to talk about this initiative. A blast from the past. So in the first episode here, which was with Luke Knies. He told me that one of his worst business choices was to somehow not follow up some of problems you had with Puppet at the times, which led you ultimately to create a Chef, and so in some way start create the background for a competitor in the configuration management. I would say with the thinking about that now, I guess it has been a good thing for you, for sure. Maybe also for Puppet and Luke, because it's a way competition has been good for both. How do you remember those old times where Chef was the beginning of Chef?
Yeah. I mean, I remember them as hard. I mean, they were also really fun. But yeah, I mean, I didn't want to make Chef, right? I had a Puppet consultancy basically that was doing fully automated infrastructure. We were killing it. I was selling Puppet all the time and was good at it. And I think we were just ahead of a lot of the problems that the Puppet community was going to see later. You know, a lot of the people who were using Puppet, they were smaller, they were in academia, they were in, or they were in a single organization. Our consulting company in a year, we were running more than a dozen companies' infrastructures, kind of on retainer using Puppet. And if you think about how many people had actually deployed Puppet a dozen times in different environments for different workloads that were trying to fully automate the entire stack at that time, it was basically us, we were it. And there were some others, but I don't think so, or I don't remember who they were, which doesn't mean they didn't exist. It just, it was a small community was the way to think of it. And we were just ahead. And so a lot of the problems that we saw were problems that if you hadn't felt them, felt like it was just us, holding it wrong. So a good example was eventually Puppet solved this problem, but the way that it works under the hood is that it builds this big DAG of all of the stuff that you build. Terraform does the same thing, right? So it builds this directed acyclic graph of all of the components that you've done. And then in Puppet's case, it does a topological sort, because if you're doing operating system configuration management, operating systems do not want to be configured in parallel. They just don't. You can't, you can't call apt in parallel, right? If two people log into the server and run apt get update at the same time, it blocks you. There's a lock, right? Or it just fails. And so configuration management on servers in the end is linear, right? And you'd like it to believe that it's not, everybody has the dream that wouldn't it be cool if it wasn't, but it's just a dream. In fact, it's linear. And so what happens is you build this big graph, then you sort the big graph, then you linearly walk the results of this topological sort. A property of topological sorts, as the graph gets larger, is there multiple valid sorts through the graph, right? So it's just the math, right? The bummer with that means that when you apply that to configuring an operating system, some of those paths will work and some of them will not. And the graph nerd answer there is, well, you should have specified your dependencies correctly, right? So that the graph always has everything it needs in order to complete successfully. Fair enough. True sentence. And when you have 30,000 resources on a single machine, the number of sorts available to you are so big, and you can't really reproduce the bug that was how the sort went wrong. And so how do you fix the fact that you go to a customer and you're like, okay, I want to deploy this automated infrastructure you built me. It works perfectly out of the box, really fast, one time, 100 times out of 200. So 50% of the time it works great. And then 50% of the rest of the time it fails for reasons we don't understand and can't reproduce, because if we just did it again, it would just work. That was very frustrating. And at the time, they just didn't want to hear it. They were like, the problem is you. Stop being a dummy. And I'm like, I'm not a dummy. This is going to be your problem too when you get to this larger size. And so, it was frustrating to be in a moment where there was this thing that I loved and this community that I could have loved and did, and it helped my career in so many ways. And also they They were not interested in what I had to say. Now, to give them some credit, I wasn't exactly saying it in the most, was I being my best, most polite self? Was I the
You were
most,
not so cool.
Yeah, at the time I was in my 20s. Now I'm in my 40s. So like Adam today, I'm pretty sure could have navigated that complexity and gotten everybody where they needed to go. Adam in my 20s, like I was much more likely to just blow them up, but like you mentioned Nigel, like I described what I just described to you to Nigel once, where he was like, why is this really such a big deal? And I like sat him down and I walked him through all the math. And I was like, and so the way you fix this is by weighting the graph. Like if you just add a weight to everything that comes through here, then you will suddenly always get the same sort. And now both the bugs are easier to find. And my supposition is that you'll eliminate most of them because most people just write it in order. Like we think linearly anyway. So just make it linear. And, his response to that description, I did all this stuff. I showed him the math. And he was like, I just don't believe you that it works that way. And I was like, which part don't you believe? Like, you don't believe the math? You think math doesn't work that way? And he's like, well, no. And yes, because you have a vested interest in how the product works, in the choices that you've made, in the castles you've built in your mind, and this is just what people do. And it's not like Nigel's not a dummy. He's great. He's smart and kind. And like, I have deep and abiding respect, but like the circumstances in his life did not allow that conversation to turn into one where he was like, yeah, I get it. We should change, because the inertia to change was pretty high. His boss was like, this is the road to hell. We'll never do it. Those guys are the enemy, like there's a lot of inertia there that isn't just the thing. And for me, I just am over, I don't ever want to be in a situation where where the software I'm building, where the people, I don't need enemies, like, and when I look back at that era, what I see it as is a lot of sort of needless enemy creation, sort of all around, where like, maybe it was good for the industry. Maybe it was fun for a minute because people like to argue. But ultimately, there's just all these people that I really like and that I really respect. And I think and we're all like nerdy about this very niche thing. And I just think we could have all been friends. And instead we were sort of warring camps. And, whether we had wound up competitors or not, like, I want to have relationships with my competitors where we enjoy the game. I want, when you watch like professional athletes play, like they're intense when they're playing the game against each other, but they have relationships with each other outside the moment that they're on the court or the pitch or whatever, playing their competitive game, because there's very few people who understand the circumstances that you're in, who understand the complexities, the problems, the difficulty, the struggle. And like, you need those people if this is the work you want to do and you want to do it at the highest level. And so it really changed my perspective about how I think about building a competitive company now, where like, I've helped multiple people who will probably compete with System Initiative get seed funding. And like, there's probably some version of my life where that's there's probably some strategic version where that's a mistake. But like, it's not because those people matter. The game is small. We're going to win or lose based on how we compete on the pitch, not because of how I feel about you as a person, or because I hate you because you're taking money from my family. You're not. It's fine. Does that make sense?
Yeah, definitely.
It was a long-winded answer, but that's how I feel about it.
I think also from Luke's perspective, his point was that he was so busy building the company and not making money out of it, and basically had no enough time to follow up some of the things.
Yeah, some of it was time. My perspective is that it was less about time, and it was more about the stress of trying to find a way to feed your family and
Exactly.
trying to, like, yeah, he was crunched for time. And also, like, Luke needed to win because he didn't have a plan B. Like, Luke didn't have another, there wasn't another, he didn't have another choice. Like, Puppet was his choice. He was all in, like all those chips were pushed all the way into the table. And like, I get it. And it worked, for whatever regrets he has. Like, how many people build startups that get to over 100 million ARR? It's not very many. It's a pretty small number. And people look at Puppet and Chef. I got this the other day at KubeCon. Somebody was like, "Oh, do you feel bad that Chef was a failure?" And I'm like, "Motherfucker, call me when you do it." like you let me know when you figure that out, and then you get to come and like call me a failure to my face again. And like, and did we win to? Did either of us win to the level that like HashiCorp won? No. But who would never look at me or Luke and talk about us as failures? Mitchell Hashimoto. You know why? He knows precisely how difficult that was. He knows precisely how precarious it was. He knows precisely all the different places where it could have gone a different way and not worked out for them. And like, it's a hard game we choose to play. And so if you're going to choose to play this difficult game at the highest level, sometimes you win, sometimes you lose. And like, you just cannot think about it that way. But it's hard to have that kind of magnanimous perspective when you're at the beginning of the journey, when it's like, I've got this technology, I think I can turn it into a company, I think it can transform the world, and here's Adam Jacob like telling me how wrong I am about this fundamental thing that I think will transform how the industry works, and I have all this evidence that's telling me it could work. Like, I get it, like, I don't know that I'd have listened to me either. And because the pressure that's on you and the things you need to do in order to get through it is just, it's a lot, man.
Yeah. And anyway, you did software which was used worldwide, so respect, whatever is the.
Yeah, but I guess I didn't mean it to be like. I mean, I guess it makes it sound like there was some bad thing that was happening in my life. It's not. It's just
fact.
my empathy for it is incredibly deep, and I think for a lot of people who haven't done that work or don't understand it, it's easy to look back at some of that history and sort of try to coach from the outcome, where it's like, well, if Luke had done this, then we wouldn't have done that, and this would have been. But like, in the moment where you're actually living those experiences and you're actually having to make those choices with all of the emotion and all of the feelings and all of the fear and all of the doubt and all of the uncertainty, like, easier said than done, and I just think the older I get and the more perspective I have on it, the more that's how I feel, is like, I only have more empathy for Luke now than I did then. I have more empathy for the situation he was under. I have more empathy for how hard those choices were and how difficult the position I put him in really was. And, do I wish he'd acted differently? Yes. Do I understand why he didn't? Yes. Are we ever going to be best friends? Probably not. But like, that's not because we hate each other. I hope. I don't think he hates me. I don't hate him. But just because that's the shape our lives took us in,
All right. Okay, let's close the past window. Just a few minutes to finish. Let's talk about the future.
Yeah.
Let's say 5 years from now, where will be the IT world in terms of infrastructure, and where will be some initiative in this world?
Look, 5 years from now, we won't be talking about the theory of what it would be like to automate infrastructure on top of this hypergraph of functions. This will be the way you work. And whether you're using System Initiative or you'll be using whatever the system is that somebody builds that works like System Initiative, somebody's going to do to me what I did to Luke. They're going to look at System Initiative and they're going to be like, this was really smart, except for these 5 things that were dumb. And so there's going to be like competition. There'll be multiple different ways to think about it. But we're going to look back 5 years from now at the way we built infrastructure and the way that we've been doing it so far as like a weird dark age, in the same way that like game developers when you didn't have game engines that had a model of how to build a video game, like you could build video games without those things, but it was a lot harder. And it was like, and it's not because the video games got simpler, they got more complex, right? Like, and that's exactly what's about to happen to all of us in infrastructure. And it's because we need it. Like, in order to handle the level of complexity that's happening in our lives, that's happening in the enterprise, that's even happening in our startups, we need a new primitive. We need a new way to deal and to think about the problem, because we've kind of pushed the existing paradigm as far as it'll go. So my prediction is that this is the way. Building it on top of a model like this that's built of a hypergraph of functions, I think, is the way that the future will be built. I think, between here and there, we've got some work to do to figure out exactly how that happens, and people have to migrate, and you don't get to skip a step, but that's what'll happen. And in 5 years, there'll be competition, but won't be the only game in town. There'll be other people who use this same theory and this same foundation in order to build even experiences and interfaces and ways of working with this information that we can't imagine right now, because you literally can't even think about building them, like, without having some kind of substrate that allows you to think about the system as information and then program the information with a model of what it means. You just can't even imagine building those products. And so we're going to start to see products get built on top of these foundations that, when you look at them, if you were to build them now, people would be like, it's science fiction, and that's what's going to happen in infrastructure. And yeah.
Oh, well, let's see. We will see, I guess.
Look, man, you asked for the prediction.
That's fine. That's cool. Actually, I like how bullish you are. You are on this.
I'm pretty bullish on it, because look, whether it's system initiative or something else, let's say system initiative doesn't work. Let's say that I got it wrong in some way.
But the concept, you mean the concept of infrastructure as model?
Oh, I am not wrong about the problem, and I'm not wrong about this. I'm not wrong about the shape of the solution. Like, and I've spent a lot of time, most of my adult life, just only thinking about this problem, pretty much. And like, I'm just not wrong about where the problem is. Like, that's what the problem is. And this is a viable solution to that problem. And I have enough capability and enough support that, like, I can bring that into the world. Somebody else will too. Because once it's in your head, you can't unsee it. And that's the kind of thing that snowballs. Like, it's the kind of thing that over time it becomes inexorable. And when you're starting where we're starting from, it's a mix of hubris and crazy to say, hey, 5 years from now, this will become the dominant primitive. You're like, no, it won't. Like, that's crazy. There's all this infrastructure as code that already exists. There's all these systems we have to convert. There's all these mainframes. There's all this stuff you still have to do. It's a huge lift. All that's real. And it doesn't matter, because sometimes when the fundamental technology is true, that's what you need. 5 years into the cloud, you could still realistically sit around with your arms crossed and be like, no, data centers are better, but like, you can't really do that now, and but it was inevitable. We knew it was inevitable, 5 years into cloud, and 5 years from now, it'll be inevitable that way.
Wonderful. I would say let's close with this prediction, and I wish you will be true and right.
Me too. Thank you.
Of course. And thank you, Adam. It has been wonderful to talk with you.
It's always a delight. I'll see you in Ghent. I look forward to it. If you're listening to the podcast, you too should come to Ghent. It's the best conference on this topic anywhere on earth. You should fly to Belgium and get it done.
We will meet all there.
Yep, it'll be awesome. We'll buy you a beer.
Bye.